Hello, kiddos. We are going to do a quick video today on ASA and AAS, two more shortcuts that you can use when completing triangle proofs. So the first one, ASA, stands for exactly what you want it to stand for, angle, side, angle. And what that means is if you have two angles in a triangle, congruent to two angles in another triangle, and you have the side in between the angles, it has to be the side in between, then we call that ASA. Okay, now we're going to add this to our bag of tricks that we had last week, which were SAS, two sides and the angle in between, and SSS, all the sides. So this is just another shortcut like those, but it's ASA. So if we come down here and we do exactly what we did last week and we say, all right, what does ASA look like? On part A, I have the two angles. There's an angle right there. There's an angle right there. If I want it to be ASA, I got to mark the side right in between the two angles. And if I come over here to B and I want this to be an ASA picture as well, I have an angle right here, a side right there. I need the other angle on the opposite side of that side. Okay, or I should say next to that side. Same thing over here. There's an angle, there's a side. I need the angle next to the side. The side has to be in between the two angles no matter how I turn it. All right, what's it look like? So if we come down here to this picture and we are given some information, we are given that angle CBA, well, CBA would have its vertex at B, is congruent to angle DBA. That would be this one over here. I've marked that. And AB bisects CAD. So CAD is up here and it gets cut in half. Prove that these two triangles are congruent. Okay. So statement number one, we've rewritten the givens. And reason number one is always going to be given. Then, whenever you're doing a proof, the next thing you really want to do is re-look at your givens to see if it leads to more congruence information. It does, because my givens use the word bisect, and bisectors create equal parts. Which parts? Well, these parts. I'm going to call that angle 1 and call that angle 2 and say angle 1 has to be congruent to angle 2 because bisectors create two congruent parts. And in this case, those parts are angles because it was an angle bisector. All right, nothing in my givens gives me any more information. So now what I'm going to do is just look at the picture itself and say, is there something about this picture that would let me use another reason? And if we look at this, you'll notice that the two triangles butt up against each other right at side AB. And when they do that, when the two angles stick together at a common side, we get to use the reflexive property. And now I'm going to look at my picture again and say, all right, what have I marked? I've marked three things. I've marked an angle, I've marked another angle, and I've marked the side in between. I have created an ASA scenario. So now I can finish my proof by saying that triangle CBA is congruent to triangle DBA by angle, side, angle congruence. And that's it. All right. If I come to another one, we've got another shortcut on the next page, AAS, which stands for, you guessed it, angle, angle, side. This is for when you still have two angles, but instead of having the side in between, you've got a side that's like off to the side. Angle, angle, side is for when you have two congruent angles and an extra side, just not the one in between. Okay, so this is angle, angle, side. And just like before, we're just going to use this as another shortcut. So I will come down here and do some marking and say, all right, here's angle, angle, angle here, angle there. If I wanted to mark another side, guess what? I have options. I can say it's angle, angle, side using this side. But if I do that, it needs to be angle, angle, side with the exact same corresponding side in the other picture. Okay. I wouldn't, for example, be allowed to do this. Nope. Has to be angle, angle, side in the same order as it was in the first place. I could have also, though, done angle, angle, and then the baby side. Angle, angle, and then the baby side here. Doesn't matter which, okay? So pick one, mark them on your diagram, and I'm going to go back to my original and be done with it. Over here, I have an angle. I have a side. If I want this to look like angle, angle, side, I need to mark congruent the other angle that is not touching that side. So my only option here is if I want this diagram to look like AAS, it's got to be this angle, and the side they've already given me. So 2 angles and then that side. All right, let's come down here. Example 4, given that BD bisects ADC. BD bisects ADC. So I have that. And DAB is congruent to DCB. Prove the triangle's congruent. Okay, so let's come over here and say, well, they rewrote the givens. So my first statement and my first reason is always going to be your givens. Then I'm going to look back at the givens and see if there was a word or a symbol that leads to congruent things. There is. I got that word bisect again. So that angle gets bisected. I'm starting a lot like we started on the last one. Angle 1 is congruent to angle 2 because a bisector creates 2 congruent parts. Okay. So let's see. All right. And then when I look at my picture now, I realize, wait a second, I've got 2 angles that touch again, or 2 triangles, pardon me, that touch again. And when they touch like that, I have a reflexive property that says that the 2 sides that they share, really the one side that they share, has to be congruent to itself. So DB is congruent to DB by the reflexive property. And now if I look at the picture that I have here, I have an angle up here, I have an angle right there, and I have the side that is not between them. So this is AAS. Okay, so get that jotted down. And now you'll realize we have 4 separate ways to prove triangles congruent. We have SSS from the other day. So if I got done with a picture and I realized, oh, look, I've marked all 3 sides, then my last line would be that the triangles are congruent by SSS. We also have SAS from before, where if you don't have all 3 sides, 2 sides in the angle between them would be SAS. And then today we said, well, what if instead of multiple sides, you had multiple angles? Fine. You could have ASA, 2 angles with the side in between, or AAS, 2 angles and the side not between them. Okay. So there are 2 more left in these notes. It could be any one of those 4 rules. Let's see what we end up with, and that's what we'll finish with. I should probably use a thinner pen though. So on this one, it says we are given that M is the midpoint of HP. Okay, fine. And angle H is congruent to angle P. Okay. We're going to start this proof like every proof gets started forever. We're going to start with our givens. So I'm going to rewrite that M is the midpoint of HP, and the measure of angle H equals the measure of angle P. I don't know if we've said this before, but when you see a little m in front of the angle symbol, it means measure of. It's just another way of saying that angles are equal. Okay. And that's given. Now I'm going to look in my givens to see if I can find any congruent things. Well, this word midpoint tells me that HP gets cut in half. So if HP gets cut in half, I know that HM is congruent to MP because midpoints create two congruent segments. Then the fact that angle H equals angle P doesn't really lead me anywhere else right now. Okay? So what I'm going to use next is I have those bow tie triangles. Bow tie triangles always have these vertical angles with them. Okay? So those are vertical angles. I'm going to number. I'm going to call this one 1 and that one 2 and say, you know what? Angle 1 is congruent to angle 2 because vertical angles are congruent. And then, last but not least, I'm going to look at my picture and say, well, what have I highlighted? I highlighted an angle, another angle, and that side is in between the angles. So I have ASA. So I'm going to finish this off with triangle GHM congruent to triangle RPM by angle side angle congruence. All right, last one. So down here, we've given some extra information in the proof diagram. So let's see what's going on. It says given angle BAC, that's one there, and DCE are congruent. And you might be thinking, hey, maybe they're congruent because they're right angles. They didn't say they were right angles, so we can't assume that. All we know is that they're equal. All right, so BAC and DCE, those are congruent. I marked it. AC equals CE. I marked it. And BC is parallel to DE. Okay. So how are we going to start this thing? Well, number one is to give the givens, and I've got that. And then when we have parallel lines, one of the things we told you to look out for were alternate interior angles. And there are some alternate interior angles in here, but they're not very helpful. So don't write this down. I'm going to use yellow just so it easily disappears. Alternate interior angles happen when you have like the letter Z. So if I look at this letter Z right here, this angle and that angle would be congruent, but that's not helpful because this angle right here in between isn't even part of a triangle. So I'm going to ignore those alternate interiors. Are they there? Yes. Are they helpful? No. And I'm going to look at the reason we had here that said don't look for alternate interiors. This time we're going to have some corresponding angles. And the corresponding angles that we're going to see are this one and this one. Those two angles are corresponding angles because they're in the same position relative to the parallel lines. If I look at these parallel lines, this is like at the bottom and to the left. Here's another parallel line. This angle is at the bottom and to the left of that one. So those two angles, I feel like giving them three letters. That would be angle BCA and angle DEC. Whoops, forgot my angle symbol. Angle BCA and angle DEC are congruent because corresponding angles are congruent when lines are parallel. And then I have a whole bunch of lines, but I don't think I need them because I have an angle right here, an angle right there, and the side in between, I have ASA. So I'm going to say triangle ABC is congruent to CDE by angle, side angle, congruence. And that, my friends, is that. So you have finished your notes on all the shortcuts. You actually have all the shortcuts you need for right now. And you are going to go into the lesson 5 homework in your homework packet and work on that. So have a beautiful rest of your day, even though it's cold outside. And I will see you all later. Bye.